We will begin the debate with two opening statements. Each of those statements is 8 minutes in length, and we will begin with the affirmative. You are free to start.
Before we begin this debate, we congratulate the top 8 teams for making it this far, and we look forward to a great final round. My team and I would like to thank a few parties, the first being the International Public Policy Forum, sponsored by the Brewer Foundation and New York University, for giving us this incredible opportunity to practice our written and oral debate skills in the city of New York. Next, I would like to thank the judges, coordinators, and volunteers for their time, and our ambassador Vlad Pavlov for taking time from his studies and supporting us this weekend. I would also like to thank our coach Katie Schultz for her time and energy, and finally, I would like to thank our parents for showing their continuous support. Now, if everybody's ready, I will begin. Because genetically modified organisms, or GMOs, are essential to feeding billions worldwide, we affirm the resolution resolved genetically modified organisms are essential to global food security. The World Food Summit of 1996 defined food as security as existing when all people at all times have access to sufficient, safe, and nutritious food to maintain a healthy and active life. If GMOs improve any of these areas alone or with other agricultural methods, the resolution should be affirmed. Essential is defined as, according to Cambridge dictionaries, necessary or needed. Contention 1, increased yields. Higher yields are crucial for global food security. The Food and Agriculture Organization notes in order to feed this larger population, food production must increase by 70% by 2050. Genetically modified organisms uniquely solve this problem. Stephen Sexton and David Zilberman from the National Bureau of Economic Research report on February 2012 that after examining every GMO-adopting country, yield gains for GE cotton and maize are estimated to be 65% and 45.6% respectively. Yield gains for herbicide-tolerant rapeseed and soybean are 25.4% and 12.4% respectively. Holistically, a meta-analysis by Willem Klumper and Meteen Kame from the University of Göttingen concludes that GM foods have increased crop yields by 22% and increased farmer profits by 68%. Increasing income is also crucial to ensure food purchasing power. Graham Brooks and Peter Barfoot write in GM Crops and Food in 2015 that direct global farm income benefit from GM crops was $20.5 billion. Meteen Kame and Shazad Kauser conclude in the Public Library of Science on June 5, 2013, that GM cotton has reduced food insecurity by 15 to 20% among cotton-producing households. GMOs increase yields and income, essential aspects of global food security. Contention 2, environmental benefits. Subpoint A, conservation. GMOs conserve the environment, providing for future food security. Gaia Vince from the BBC reports on September 21, 2011, that around 85% of global fish stocks are overexploited, depleted, fully exploited, or in recovery from exploitation. However, the World Health Organization finds that 1 billion people rely on fish as their main source of animal proteins. Fortunately, Heidi Ledford finds in Nature Journal that genetically modified salmon is the first genetically engineered animal to be approved for human consumption in the United States and can grow to market size in 18 months, meaning that it can conserve fish feed and farm space while producing more food faster. Clive James from the International Service for the Acquisition of Agribiotech Applications finds on March 25, 2014, that GM crops have reduced CO2 emissions by 28 billion kilograms in 1 year, equivalent to taking 12.4 million cars off the road for 1 year, and conserved biodiversity by saving 132 million hectares of land. Environmental conservation from GMOs is critical to sustainable global food security. Subpoint B, reversal. GMOs can actively combat environmental degradation. Christian Walter et al. Writes in Nature in 2010 that 1.4 million Bt poplars have been planted in China on an area of 300 to 500 hectares. Roger Sedgwick writes in 2005 that this great green wall of forest is being established to help control impeding desertification. Coco Liu from Scientific American concludes on April 24, 2011, that these efforts offset roughly half of the carbon loss by tropical deforestation. Yet another way to offset greenhouse gas emissions is with GM crops. Su et al. Writes in Nature on July 30, 2015, that rice paddies are the largest anthropogenic methane source and produce 7 to 17% of atmospheric methane. However, a genetically modified form of rice called Sosiba 2 rice was associated with a significant reduction in methane emissions. Since GM foods are crucial for environmental conservation, they are essential to global food security. Contention 3, social benefits. GMOs can provide societal benefits which in turn provide for global food security. This stems from diminished labor costs from farming genetically modified crops. Justin Gardner, Richard Nehring, and Carl Helston write in Ag Bioform in 2009 that adopting HR soybean under conventional tillage reduces household labor by 14.5%. This provides a variety of benefits. One is reducing population growth, as the World Bank asserts in 2004 that parents choose to have smaller families when they do not have to rely on their children to work on the family farm. Smaller families mean less mouths to feed, improving food security. In addition, GMOs further women's development, as The Economist continues on October 29, 2009, that on average, each birth reduced by a fifth the likelihood that a woman would have a job. Wynn et al. From Global Aquaculture Advocate continues in November/December of 2011 that GM crops may improve the living standards of poor people and contribute to gender equality via the creation of employment for women in rural areas. This is crucial to food security because the Asian Development Bank writes in 2013 that gender equality is the single most important determinant of food security. 43% of the reduction of hunger that occurred in developing countries was attributable to progress in women's education. Developments in women's education and slowed population growth through GMOs directly lead to global food security. Contention 4, situational tolerance. Subpoint A, climate change tolerance. As climate change continues, GMOs allow crops to adapt and thrive. Paolo Castiglioni from Plant Physiology writes in June of 2008 that in North America alone, it is estimated that 40% of yearly maize crop losses are due to suboptimal water availability. Transgenic entries provide a yield increase of 4.6% under water stress, with the two best performing events demonstrating advantages of 38.8% and 18.3%. Lin Hui Yu et al. From Plant Physiology also finds in July of 2013 that GM rice produced 77.39% higher yields than conventional rice under stress conditions. Peter J. Franks et al. From the New Phytologist continues in 2015, GM rice increased both instantaneous and long-term water use efficiency without altering significantly the photosynthetic capacity. Increasing plant growth under stressful conditions make genetically modified foods essential to global food security. Subpoint B, disease tolerance. Crop diseases threaten global food security, but genetically modified foods uniquely solve this problem. Pamela Ronald writes in Genetics Journal in 2011 that genetically engineered papaya yielded 20 times more papaya than non-genetically engineered variety after a PRSV virus infection. As a result, production rapidly increased from 26 million pounds in 1998 to a peak 40 million pounds in 2001. Today, 80 to 90% of a Hawaiian papaya is genetically engineered. Potatoes have also been engineered to be disease tolerant. The James Hutton Institute reports on December 28, 2012, that potato blight still poses a significant threat to global food security. The problem is particularly acute in emerging countries in Africa and Asia. However, Jonathan Jones et al. From the Royal Society reports in 2014 that after introducing one gene from wild relatives into cultivated potato, no signs of infection were observed on transgenic plants. Yet disease progressed quickly on non-transgenic desiree plants, with 100% infected tissue observed and almost all plants dead and without any foliar tissue. Nicholas Staropoli continues for the Genetic Literacy Project on January 14, 2016, that this potato has been approved by the FDA and reduces the amount of carcinogen that is produced when the potato is fried. Finally, Paul Vusin from National Geographic reports on September 13, 2014, that a strain of citrus has been created that is resistant to citrus greening, which plagues 80% of Florida's citrus trees and is spreading abroad. Attempts are being made to deregulate this strain of citrus following the steps of Hawaii's genetically modified papaya. Therefore, providing disease tolerance is a crucial reason that GMOs uniquely contribute to global food security. For the aforementioned reasons, we affirm.